circuits with independent sources. The problem is to determine I sub 0 in the circuit shown below. The circuit has one independent voltage source and two independent current sources. And the way we're going to solve this problem is using mesh analysis. So we know that when we're doing a problem and solving it using mesh analysis, that we're looking for the mesh currents. Ultimately, if we can find the mesh currents, then we're able to find any other important quantity that we're interested in our circuit. So when we're performing mesh analysis, the first thing we do is we assign our meshes and our mesh currents. So we're going to start with the lower left-hand corner, and we're going to assign our first mesh, and we're going to assign a direction as clockwise for that mesh. We're going to assign the second one to the top mesh, again clockwise for mesh 2, and then we have a third mesh, which is the lower right-hand side, and we're going to assign current I sub 3 to that mesh. So we have our three meshes assigned, and we have mesh currents assigned. The next thing we do when we're performing mesh analysis is we sum up the voltages around our meshes, ultimately so that we can find the values for I sub 1, I sub 2, and I sub 3, our mesh or loop currents. So when we look at this first mesh and we try to do that, we see that we can certainly sum the 12-volt source, and we can certainly sum the voltage across the 2 kilo ohm resistor, but we don't know the voltage drop across the 2 milliamp source. Sure, we could assign another variable, maybe V 2 milliamps, for the voltage that drops across this source, but that adds another variable to the problem. And instead of just having three unknowns, I1 through I3, we also have a fourth unknown, V 2 milliamps. So in order to avoid that, we use this concept of super mesh in order to solve the problem. So if we're trying to find the solutions to I1, I2, and I3 in mesh analysis, and we have a current source which is tied between two adjacent loops or meshes, then we need to use this concept of super mesh to solve the problem. And what super mesh allows us to do is it allows us to avoid that current source when we're summing the voltages around the loop. So our super mesh that we're going to define is the one in red, where we avoid that 2 milliamp source, yet we still create another independent equation, so we have that third equation. So we're going to use this as our super mesh. And we're going to, first of all, sum up our voltages around the super mesh. So starting at the lower left-hand corner of the super mesh, we first encounter the 12-volt source and the negative polarity for that 12-volt source. So it's minus 12 volts. Continuing, we encounter the 2 kilo ohm resistor. The voltage drop is 2K times I sub 2. Continuing, we encounter the 1 kilo ohm resistor, and the voltage drop across 1 kilo ohm resistor is 1K, and then the current I2 is flowing the same direction. We're summing the voltages, so it's I2 minus I sub 3, which is flowing the opposite direction through the 1 kilo ohm resistor. We continue on our path, and we encounter the 2 kilo ohm resistor in the bottom center of our circuit. The voltage drop for that is 2K I sub 1, which is flowing the same direction as we're summing the voltages, minus I sub 3, and that's equal to 0 because that gets us back to our starting point. So that's our first equation. And we can see from this that we have our three unknowns, I1, I2, and I3. So we need to come up with two more independent equations. So if we look at our third loop, we see that I sub 3 is given to us directly. I sub 3 is equal to minus 4 milliamps. So that gives us our second equation. So we need one more equation. The third equation comes from this 2 milliamp source, which was shared by two adjacent loops or meshes. And so we know that that 2 milliamp source is going to be equal to I1, which is flowing the same direction as it, minus I2, which is flowing the opposite direction of that current source. So now we have three independent equations. We have one from our super mesh, one from mesh or loop 3, and another from our constraining equation for the 2 milliamp source. So we have three equations and three unknowns. So we can find, we already have I sub 3. We know I sub 0, which is ultimately what we're looking for, is equal to what? Is equal to I sub 1 minus I sub 3. So we need to find I sub 1 in order to solve for I 0. So if we solve these three independent equations for I sub 1, we get an I sub 1 which is equal to 1.2 milliamps. And if I sub 1 is equal to 1.2 milliamps, then I sub 0 is equal to 5.2 milliamps.